Okay guys, today we're going to do 5-4 dividing polynomials part 2, synthetic division. So you will be able to divide polynomials using synthetic division. Synthetic division, overall. So we must be dividing by a linear expression x minus a. So that is the key in order to use synthetic division. Then the steps to using synthetic division, we will first write the coefficients, including any zeros or placeholders that we need, of the polynomial in standard form. So from the coefficients from the highest exponent to the lowest exponent. We are going to omit or take away all of the variables and the exponents. And then for the divisor, we are going to reverse the sign. So that's setting up our synthetic division. We are going to use synthetic division to divide x cubed minus 14x squared plus 51x minus 54 by x plus 2. Keep in mind what we just talked about. And they want to know what is the quotient and remainder. So you are going to draw this little bar. On the inside, we are going to write the coefficients. Since we are already in standard form, meaning our exponents go from highest to lowest, we can then just use the coefficients. So 1, negative 14, 51, and negative 54. On the outside, I'm going to take my divisor and use the opposite of whatever number I'm adding. So it's x plus 2, so then I'm going to put the opposite on the outside, which is negative 2. Then, in order to divide, I bring down my 1 and I put it on the outside. I then take 1 and multiply it by my negative 2. So 1 times negative 2 is negative 2. I put that in the next column over. I add down. So negative 14 plus negative 2 is negative 16. I put that on the outside. I then multiply negative 16 times negative 2, which is 32. I add down. I get 83. 83 times negative 2 is negative 166, and I add down, getting negative 220. Now that we have completed all of the coefficients, I have on the outside my coefficients of my quotient. The way we are going to determine what variable and what exponent goes with them is by looking at the first term from our original polynomial. We're going to have our first coefficient be 1 degree less than our first term in our polynomial. So it's going to be 1x squared, or just x squared. Then minus 16x plus 83, remainder negative 220. So this would be my quotient and remainder. We are going to use synthetic division to solve a problem. So the polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of the shadow box shown. What are the dimensions of the box? Hint: the length is greater than the height or depth. So here, we have width. We want to find the length and the height. So in order to express volume, we would do L times W times H. But since we have the volume, we need to divide by our width to then find our height and our length. So we're going to use synthetic division. So I'm putting -5 on my outside, my polynomials in standard form. So 1, 7, -38, -240. Bring my 1 down, I get 1. 1 times -5, -5. 7 plus -5 is 2. 2 times -5 is -10. 38 plus -10 is -48. -48 times -5 is 240. -240 plus 240 equals 0. This is my remainder. And we know that my first coefficient is 1 power less than my original polynomial. Therefore, we have x squared plus 2x minus 48. As I keep going through my next coefficients, it's going to be 1 degree less than the term before. So now I have something that I can factor. I'm going to use triangle to factor this, -48. What multiplies to -48 and adds to 2? I'm going with -6 and 8. Therefore, I have x minus 6 and x plus 8 as my height and length. But I know that my length is greater than my height, therefore making x plus 8 equal to my length and my height equal to x minus 6. My width is still x plus 5. So the remainder theorem, if you divide a polynomial of a degree that is greater than 1 by a linear term, x minus a, then the remainder is the polynomial evaluated at a. So by the remainder theorem, p of 3 is the remainder when we divide p of x by x minus 3. So if we use synthetic division, it's the same thing as if we evaluated the polynomial p at 3. So I'm going to put 3 on my outside because it's the same thing as dividing by x minus 3. And when I'm on the outside, I need to take the opposite. I'm going to take my coefficients. So my first term is 5. My first power is 5, coefficient 1. I do not have a term with an exponent 4, so I'm putting a 0 because we need to hold that place. Then 3 is -2, -1, 0 again for my exponent 1, and then 2. Bring down my 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. -2 plus 9, 7. 7 times 3, 21. -1 plus 21 is 20. 20 times 3, 60. 0 plus 60 is 60. And 60 times 3 is 180. 2 plus 180 is 182. This last number is always my remainder. Therefore, P of 3 is equal to 182. If you would like to check, you can go ahead and take 3 and replace it for all of the x's shown and evaluate. Now you guys try these examples on your own.